Hello, and welcome to my talk. My name is Daniel Santiago, and I work for Google, specifically on the Jetpack and Android X team, and I work on libraries like Room, Work Manager, and we have a small library called Compose. I don't know too much about that one. The title of my talk is a bit of play of words, but in essence, we're going to talk about Android X SQLite. And this picture sort of describes it well where it's at. It is this small library in this big pile of other things as a dependency, small but powerful. So I think I'm going to try to give it 20 minutes of fame, which is this 20-minute lightning talk. Specifically, how for Room KMP we had to do some things, and we have some new APIs that might be cool. But let's start with some definitions. What is Room? If you've never heard about it, it is just an Android X library that helps you use SQLite databases in your app. It uses annotation processing and code generation. That's about it. Room uses Android X SQLite, and this definition, you might have not seen it, but Android X SQLite is just a library that has interfaces to help you build other libraries that use SQLite, like Room. And then if we keep going down on that dependency tree, we have SQLite itself, which it's worth defining because a lot of people just take the name as is, mainly because when you use it, when you use SQLite, you're using either Room or SQLite, or maybe you're using the Android APIs and you don't kind of like interact with the actual SQLite. But in essence, it's a C library, it's small, fast, and self-contained. And it's an SQL database engine. And this is important because it makes it like a perfect database library for mobile operating system like Android and iOS. And fun fact, even Windows used to have SQLite, Windows phones, rest in peace. So what exactly are those interfaces that Android X SQLite has? Well, we call these the support SQLite interfaces, and to put it simply, they're just mirrors of what the Android APIs are. If we look at the actual APIs, you have APIs to read from the database, you have APIs to write on it, and then you have some other transaction APIs, and these are like on its own category because SQLite does it differently. But in essence, it is just an interface to backward compatibility, and that's how we mostly been evolving it, by adding backward compatible APIs. So for example, in Android 15 and SDK 35, we added like a new method and we made it backwards compatible. But it is also a mirror of the Android APIs. So we have some APIs like this one that I don't know what it does, so don't ask me about it. And then the other thing is we do expose cursor, and we never made like a support cursor. And cursor is, very Android. It has like these things. I don't even know about them, but maybe that's not so bad. Overall, you don't implement these interfaces. You just use an already created implementation for them, which we provide through SQLite framework. Again, it implements those interfaces. It has fixes for framework issues, and the entry point to it is through the framework SQLite Open Helper. So, kind of like problem solve. If we were to summarize what Android X SQLite is again some support interfaces. Original idea was, again, backward compatibility and easy migration to Room. We already have an implementation of them used by Room, and the Android driver in SQLite also uses it. And then technically, because these are interfaces, some people have built things on top of it. So for example, SQLcipher, which is a library for encryption, they have an implementation of these support SQLite interfaces. And separately, Recurry Android is a version of SQLite compiled from source, included in your APK. They also implement these interfaces. And you would say, well, that's the end of the story, but enter Kotlin multi-platform into the Room and to consume my life. And we did announce Room KMP earlier this year in Kotlin Conf. There's a photo of it as evidence. But essentially, when we made Room KMP, we started to target iOS, Linux, Mac, and you quickly maybe realize room KMP means we need an Android X SQLite or some SQLite abstraction that's also KMP. And that's kind of like the main point here. So we had to create an SQLite kind of like driver APIs, and that's what I'm gonna walk you through a little bit now. So these driver APIs, they're very similar to the core C SQLite APIs. There's a driver, it's the entryway to it. You open connections. SQL connection is like the closest thing you have to a database object, but you can technically have more than one. And then the main thing you interact with is a statement. It's how you prepare an SQL statement and then write and read. And it has a life cycle. You get one from a connection. If it has parameters, you put more, maybe none or more, and then you execute it. And executing it can be running it once if it's like an insert, or maybe multiple times for each row if you're reading. And then these are resourced, so at the end of it, you do have to destroy them. And they're really small, like the whole interface, the two interface fixed on a slide with some cheating, like the bind and get, they are multiple bind and get, but it's pretty small, which makes it really nice if you want to extend it. And I'll show some examples. Similarly to the support library, we did have already implementation for them that you can use, the Android one, a native one, but specifically I want to call out on the bundle one, because that is kind of like what we recommend you to use now in Room KMP, and even if you're using Room in Android alone. And the reason is because, well, for one, it has the most up-to-date SQLite. So if you don't know, because SQLite was part of the framework, the version of the OS that your app was running on defined the version of SQLite. So, and if you have Min SDK 16, 18, maybe you don't, or 21, then you might be missing on a few features. Aggregated function, window function, and things like that. So by using a bundle version, you do get the most up-to-date. It's consistent, again, so because you have a single SQLite version, all devices, no matter where your app runs, it'll use the same version, so you have the same set of feature. It's also a small performance upgrade, especially on big queries and transactions, because the original Android bindings, or the SQLite in Android, was made with some restrictions, memory restrictions, a long time ago. And if you know or seen or heard about Windows and Cursor, what that meant is the OS would reserve like 2 megabytes, put the data there, and that was shareable. And that was kind of like the original purpose. So when you try to get SMS from a content provider, the Cursor was like an inter-process communication way of doing that. But most apps don't need to share their data out of their own process. So we basically eliminate that, and that's a performance gain. But nothing in this world is free. You do get an increase of APK because it does ship with a native component. It's not so bad when you're delivering to the Play Store, because the Play Store will only deliver the architecture for the phone that's downloading it. So it's not so bad. Let's go through an example, see how you use it, because the cool thing about it is you can use it on Android, but you can also use it as a standalone API for maybe your small JVM app or your small native app. And so we have a main function here. You start by creating a driver, which is the entryway. You open a connection, you give it the file path, and then let's say we're kind of set up our schema, so we create a table. We have an utility function here called execute SQL. It's just prepare a statement, execute it once, and that's kind of it. If we want to insert some data, we have some bind, some parameters here we want to bind to. So again, we prepare a statement, it's a resource. We use the use function from autoclosable, and then we bind some values here, the ID, some text, and then eventually we do execute that statement. So let's say that was the setup. If we were to read, similarly, you prepare a statement, and this time we might get more than one row, so we have a small idiom where you basically do a while loop. And the step function is one that will return true or false if there's more rows to read. So as long as if it keeps returning true, you got like one more row to read and get data out of. And then the get text is how you get like a column value. And then at the end of it, it's a resource, so you close it. So it's pretty simple and it's pretty small. Using it in Room is pretty easy. So now we have a set driver API. But then again, you can use it as a standalone for your KMP small app. It might be, again, in JVM native or iOS. And then you open a connection. And the thing I wanted to call out here is that very similar to SQLite C APIs, you can choose your threading mode. So maybe if this is a script, then you don't need to specify a threading mode. But if you have something more complex, you're using coroutines, that you might want to use a serialized mode so that your connection is protected. Because there are some rules on SQLite and multi-threaded. You cannot technically use a connection concurrently. So they do have some flags to either protect that or you make a connection pool. Yeah, and then some examples of things you could do with these APIs, like say you could do some logging. You can add logging. You could add, maybe you want to, before you open a database, you downloaded it and you want to like show, put it on a package first, or maybe you're adding encryption. So those are some ideas. Ooh, and I do have a demo because I thought it's not great telling you these ideas and not actually showing them to you. So I did went ahead and implemented all three of those drivers at the same time. So I have a super small app here that will have a database that's gonna be, it's in the asset folder and it's gonna get copied. It has some logging and it has encryption, all three of them. So let me just open the app here. If I show you a little bit of the code before I go through the example, this is some view models. I'm using Compose, and eventually I do have an open database here. But this is the key part is that I'm trying to set up the driver here, and I went with like a builder extension type of API, where like with copy from essentially just creates a copy SQLite driver that at the moment I'm about to open a connection, I might copy the database file from somewhere else. In my current example here, I'm gonna grab it from the asset folder. Meanwhile, the login driver, through Kotlin delegation, you can like build on top of each other. The login driver simply opens connections, and these connections are, logging SQLite connection, but all they really do is just call some Lambda at the moment a query, an SQL is being prepared, and with that you can basically log or do other things. So I just log into logcat, and then I give this to Room. So if we were to walk through my example, here I try to put boo, but turns out that's not the password for my encrypted database. It is something else. So if we look at the driver here in implementation, very similarly, through some delegation, but not this one because this one uses SQL Cipher from source. We passing the password, and if that doesn't work, we do throw an invalid exception, and that's what the UI is trying to show here. But if we put the right password, we'll get something here, some of the data that we see. And then we can also probably like insert something. We can say like, the Android community is awesome. Well, and that's not a secret, but we'll put it here as a secret. And then in our logcat, which I already have it filtered, we can start to see some of this, statements that were being logged because I added like a logging driver. So we have an insert here, insert or abort, right into my super secret entity table. And then just to like kind of show you that it is sort of indeed a encrypted database, we're gonna go ahead and grab here the database from our data folder. Hopefully you can see some of this. It should be at the end. Yeah. So we can grab all these files. These are my secret DB. We're gonna throw them in this folder here that I already had. And then there's this tool called SQL Browser, which is pretty cool because it lets you open SQLite databases, and it actually has SQL Cipher included in it. So if we go to our, not here, let me try and get this out again. Probably save it on the wrong file. There we go. Boom, boom, yep. If we try to open that database that was created with SQL Cipher in Android, SQL browser will be like, hey, it's unencrypted. What is the password? And if we do that full password, we'll be able to see the content that we added, which was that the Android community is awesome. And so like this demo kind of like shows you, the things that you can do. As in like you can grab that driver because it's so small, you can keep extending it with other things that you want. Maybe you have better ideas. But those are 3 examples that I had. And that's it. Here's a QR code to the GitHub sample, and that was super quick. So I have like 4 minutes of questions.